Okay, dear students, we can discuss the second exercise. Actually, the second exercise is based with the fundamental theorem of arithmetic. In introduction part, we discussed what is fundamental theorem of arithmetic. What is that? Every composite number can be expressed as product of primes. So, based with that, the second exercise. The second exercise, first question. Express each number as the product of primes. They giving the composite number. We want to express this composite number as the product of primes. Look at the first question, 140. How can we express this 140 as the product of primes? The same easy method we are following. 140 divide with the least prime number that divisible with this 140. That is, we can divide with 2. 2 in 140 how many times? 70 times. Then again we can divide 70 with the 2. Again with the 2, that is 35. Then we can divide 35 with which number? We can divide 35 with the 5. So 35 divided by 5, 7. So 7 divided by 7, 1. So we can stop here. So we can express 140 as 2 into 2 into 5 into 7. How many times 2 is coming? 2 times. So it is 2 square into then 5 into 7. This is the answer. So we express the 140, the composite number 140 as the product of primes. 2 square into 5 into 7. Look the second question. Second question is 156. Write 156 like this way. You can divide it with 2. 2 in 156 how many times? In 15 it is 7 times. Then remainder is 1 in 16 8 times. So 78. Then again with the 2. 2 in 78 how many times? 39 times. Then with again with the 3 in 13 times. So you can write this 156 as 2 times is coming 2 square. Only 1 3, that is 3, and 13, that is 13. So 156 we express 2 square into 3 into 13. Once again 156 divided with 2. 2 in 156, 7, 2, 14. 15 minus 14 is 1. 1 and 6 together you can say 16. Since 16, 2 in 8 times. Now here 78. Look, 78 plus 78 is 156. Then again you can divide 78 with the 2. 39 you will get. Then with the 3, 13 you will get. So 156 is 2 square into 3 into 13. Look the third question. 3825. We can divide 3. What is the sum of 3825? You can divide 3825 with the 5, or you can divide. You can check. 3 plus 8, 11. 11 plus 2. What is 11 plus 2? 11 plus 2 is 13. 13 plus 5. 13 plus 5 is 18. So 18 is actually the multiple of 3. So you can divide 3825 with the 3. Divide 3825 with 3. 3825 divided by 3 is 1275. The last number is 5. You can divide it with 5, or just add and check whether it is divisible with 3. It's divisible with 3. Then again with 3 you will get 425. Then again with the 5 you will get 85. Then 5 you will get 17. So it's stop. 17 is a prime number, so we can stop. So you can write 3825 as, how many times 3 is coming? 2 times. So it is 3 square. Then 5 also coming the 2 times, so 5 square. And the next last one is 17. So 3825 you can write 3 square into 5 square into 17.
Find the LCM and HCF of the following pairs of integers and verify that LCM into HCF equal to product of two numbers.
Okay. What is the second question? Second question is we want to verify whether LCM into HCF of two numbers is equal to product of the two numbers. The first question is 26 and 91. So we want to express 26 as the product of primes and 91 also as the product of primes. So 26, divide 26 with 2, you will get 13. So you can write 26 equal to 2 into 13. Then divide 91, express 91 as the product of primes. 91 here we are dividing with 7, 13 times. This 13 is a prime number, so we can stop here. So we are expressing 91 as 7 into 13. So we want to find next, we want to find HCF and LCM. What is HCF? Highest common factor. So we are taking only the common one. In common one we are taking the least power. Here the common is 13 and here 13. 13 is the common one. In both the case 13 is the same power, 13 raised to 1, 13 raised to 1. So we are taking HCF as 13. And for finding the LCM, we are taking the common one. In common, we are taking the largest power. Common here is 13, same powers. Here we are taking only the 13. 13 into, then we are taking all the non-common numbers 2 and 7. 2 into 7. 13 into 2 into 7 is actually equal to 182. So SCF is 13 and LCM is 182. Next is the verification part. How we are verifying this one? Check what is LCM into SCF. LCM is 182, SCF is 13. So 182 into 13 is 2366. And the product of the numbers, what are the product of the numbers? 26 and 91. So 26 into 91 is also equal to 2366. So LCM into SCF is equal to product of the two numbers. So we can write here LCM into SCF is equal to product of numbers. Product of number. Next question. Next question is 510 and 92. Same method we are following. We are expressing 510 and 92 as the product of primes. So check, the first one is 510. We can divide it with 2. 2 in 510, 255. Then with 5, 51. So we can express this 510 as 2 into 5 into 51. And 92 with the 2, 46, again with the 2, 23. So we can express 92 as 2 times is coming, so 2 square into then 23. Next we are finding the SCF. What is SCF? SCF here we are taking only the common. In common we are taking the least power. Here the common is 2, here is 2 and here is also 2. Where is the least power? Here, because only 2 here, that means that 2 raised to 1, here 2 square. So we are taking the least power, that is 2 raised to 1. So what is the 2 raised to 1 is equal to 2. So HCF is 2. And we are taking the LCM. In LCM we are taking the common highest power. The common is 2 and the highest power is 2 square. So we are taking 2 square. Then we are taking all the non-common numbers, which is 5. 5 is not common. So we are considering 5. Then we are considering the 51 and we are considering this 23 also. What is the product of these all numbers? These all numbers product is 23460. 23460. So HCF is 2 and LCM is 23460. Then we want to verify whether the HCF into LCM is the product of two numbers. So what is HCF into LCM? HCF is 2 and LCM is 23460. So 2 into 23460 is 46920. So and then the given numbers product 510 into 92. What is 510 into 92? You will get the same value, that is 46920. So we can conclude the answer as LCM into SCF is equal to product of two numbers. Okay, next question. Next question 336 and 54. We are dividing 336 with 2. You will get 168, again with 2, 84, again with 2, 42, again with 2, 21, then with 3, 7. So you can express this 336 as 2. How many times 2 coming? 1, 2, 3, 4. 4 times 2 is coming, so 2 raised to 4. Then 3 only 1 times and 7 only 1 time. So you can express this 336 as 2 raised to 4 into 3 into 7. Then check the 54. We are dividing 54 with 2. You will get 27. Then with 3, 9, again with 3, 3. So here only 1, 2 and 3, 3. So you can write 54 as 2 into 3 cube. So 336, 2 raised to 4 into 3 into 7, 54 as 2 into 3 cube. So we want to find HCF. HCF we are considering only the common. In common we are taking the least power. What is the common number? 2 is here, 2 is here. Where is the least power? Here 2 raised to 4, here 2, that is 2 raised to 1. So we are taking 2. Then check the 3. 3 is also common. Here 3, here also 3. Where is the least power? Here on the top one, 3. So 2 into 3. What is 2 into 3? 6. So HCF is 6. Then we are finding the LCM. In LCM we are taking in commons highest power. So when we are considering 2 raised to 4 and 2, we are taking 2 raised to 4. Then we are taking 3, here 3 and here 3 raised to 3. So we are taking here 3 raised to 3. And what is the next number? Uncommon number, that is uncommon number is 7. So 2 raised to 4, that is 2 raised to 4 is 2 into 2 into 2 into 2, that is, what is 2 into 2? 4, 4 into 2, 8, 8 into 2 is 16. Then 3 into 3 into 3, that is 3 into 3, 9, 9 into 3, 27. So 16 into 27 into 7. So you will get as 3024. This is 3024. So LCM is 3024 and SCF is 6. Then we want to verification. The last step is the verification. We want to find what is LCM and SCF. That is 3024 into 6. That is 18144. And the product of the numbers, multiply this 336 and 54. 336 into 54, that is also 18144. So LCM into HCF is 18144 and the product of the given numbers, that is 336 into 54, that is also 18144. So we verified. So we want to conclude the answer like this way: LCM into HCF is equal to product of the two numbers, or you can write LCM of 336, 54 into HCF of 336, 54 equal to 336 into 54. This is the method.
Find the LCM and HCF of the following integers by applying the prime factorization method.
Next question, they given three number. We want to find the LCM and HCF of the three numbers using the prime factorization method. 12, 15, 21. First of all, listen one thing, that LCM into HCF of two numbers is equal to product of the two numbers, but in three case it's not applicable. So 12, 15, 21. Prime factor is 12. What is 12 actually? Actually 12 is 4 into 3. 4 you can write 2 square, then 3. So 12 is equal to 2 square into 3. Then 15. What is 15? 3 into 5. Then 21. What is 21? 3 into 7. Next we want to find the HCF. What is the HCF? Highest common factor. Then we are considering the common in all three cases. What is common? Here 3, here 3, here 3. So what is the HCF? HCF is 3. And look, the LCM. In LCM we are taking the first the common. What is the common here? 3 is common. 3 into. Then we are taking all the non-common numbers. Here 2 square. Then here it is 5. Then here it is 7. So 3 into 2 square into 5 into 7. What's the answer? 420. So HCF is 3 and the LCM is 420. Look the next question. 17, 23, 29. Look, these three numbers are the prime numbers. So 17 you can write 1 into 17. 23 you can write 1 into 23. And 29 you can write 1 into 29. Only this big you can write. So the HCF is, what is common? Nothing is common. So we are taking the 1. 1 as the common number. So common for the prime numbers is actually 1. So HCF is 1. Then we are taking the LCM. LCM. What is LCM? We are not taking the 1 as the common, because 1 into any number is the that number. So 1 is not at all important here. So we are taking all other numbers. 17, 23, 29. Multiply 17 into 23 into 29. You will get double 1, double 3, 9. So this is the LCM and this is the HCF. Look the next question. Third question. 8, 9, 25. What is 8? 8 is actually 2 into 2 into 2. 2 into 2 into 2 is 8. So you can write 8 as 2 cube. Then 9. 9 is 3 into 3, that is 3 square. 25 as 5 square. Here what is HCF? Nothing is common. So what is HCF? HCF is 1. And we are taking the LCM. We are taking the LCM. Multiply all the non-common numbers here. So we are multiplying 2 cube into, what is next one? 3 square. 3 square into, the next is the 5 square. So the answer is 1800. So this is the method. Next question. Next question is, HCF is given. HCF of two numbers is given. We want to find what is the LCM of the two numbers. So we are using this one. This theory we are using LCM of two numbers into HCF of two numbers equal to product of the two numbers. That is LCM of AB into HCF of AB equal to A into B. So LCM is not given. We want to find the value of the LCM. So LCM into HCF is 9 is equal to product of the two numbers. Which are the numbers? Numbers given in the bracket 306 and 657. So it is 306 into 657. So LCM, we want to find LCM. So bring this into 9 to this side. What happens when we are taking the multiplication to right side of the equal, it become division. When we are taking the division to side, it become multiplication. Addition becomes to subtraction. Subtraction becomes to addition. So this method. So we are taking this into 9 to this side. So it become divided by 9. That is LCM is 306 into 657 divided by 9. So the answer is 223338. Once again, LCM is not given, HCF is given. We want to find the LCM. So the method we are using, LCM into HCF is product of the two numbers. So to get LCM, divide with the HCF, the product of the two numbers. So product of the two numbers is 306 into 657 divided by 9. So answer is 22338. Next is a very important question. The question is, check whether 6 raised to n can end with the digit 0. Very important question. This question is repeating most of the time in the board exam. So first of all, you want to write 6 raised to n. What is 6 raised to n? 2 into 3 all raised to n. So it is equal to 2 raised to n into 3 raised to n. So check. Here 5 is not a factor. If a number ends with the digit 0, 2 is a factor, 5 is a factor. Here 5 is not a factor. Here 5 is not a factor. So it will never end with the digit 0. Or you can conclude the answer. There is no natural number n for which 6 raised to n end with the digit 0. Next is the easy question. Explain why 7 into 11 into 13 plus 13 is a composite number. What is composite number? The number that can be expressed as the product of primes is known as the composite number. This is actually 1 mark question. So check. What is the question? 7 into 11 into 13 plus 13. What is common here? Here 13. The first part 13 is here. The second also 13. So we can take 13 commonly outside. So what is remaining here? 7 is remaining, 11 is remaining, then plus 1. Check. This is 13 into 7 into 11. Here 13 into 1, that is 13. So we are taking the common outside. So 13 into 7 into 11 plus 1. That is 13 into. What is 7 into 11? 77. 77 plus 1, 78. So it is a product of two numbers. Okay. In one number is not 1. So 13 into 78. So you can write 7 into 11 into 13 plus 13 can be expressed as product of primes. 78 also you can express as a product of prime. So 13 is a prime number. 78 also you can express as the product of primes. So you can write 13 into 78 can be expressed as a product of primes. That's why this is a composite number.
There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point?
This is the last question about a running field. This question is whether we want to find LCM and HCF. What is the question? Ravi and Sonia in a circular path running. They are running actually. Ravi complete this circle after 12 minutes. And Sonia complete this circle after 18 minutes. They are starting at the same time. They are starting at the same time. After how many minutes they will meet again in the same? Look at Ravi 12 minutes. He will complete the circle in the 12 minutes. So 12 minutes he will complete. That time Sonia will be somewhere here. After 18 minutes Sonia will reach here. So what we want to find? So the answer is definitely it is greater than 18. After 18 minutes they will be not in the same position. So the answer is definitely greater than 18. So what we want to find? We want to find LCM. Sonia 18 minutes, factorize 18 with 2, 3, 9 and with 2, 18 into 9 then with 3, 3. So you can write 18 as 2 into 3 square. And Ravi 12 divided with 2, 6 again divided with 2, 3. So you can write Ravi is 2 square into 3. So what is the LCM? What is the common? Common is 2. 2. The highest power is 2 square. And the common 3 is also common. The highest power is 3 square. So 4 into 3. What is 4 into 9? What is 4 into 9? 36. So after 36 minutes they will meet again. Once again explaining the question. Ravi and Sonia in a circle path. Ravi after 12 minutes, with 12 minutes he will complete the circle. Sonia 18 minutes she need to complete the circles. Okay, they start at the same position. So after how many minutes they will meet again? So the answer is definitely greater than 18. So we want to take the LCM. This is the method.